Today's lesson is on writing function rules, which function rules are really just equations, and they're equations that describe a function. So we'll have a table of values, and we have to see the relationship in the table and then write an equation that describes it. So here below I have just a bunch of function rules, equations, and in today's lesson we will focus on the linear form y equals mx plus b. So let's look at the relationship in this first example. We have a number of soccer teams, which can represent the x values, and then number of players required depending on how many teams there are, which would be our y values. So for one soccer team we have 11 players, two soccer teams, 22, 3, 33, 4, 44. So we want to see what is the relationship between x and y. What do we have to do to our x values to get to our y values? How do we get our y values? Well, we take our x values, and it looks like all of these we're just multiplying by 11, since it's 11 players per team. So to get our y values, we take our x values and multiply them by 11. So here we have a function rule that explains this relationship. Anytime we plug in an x value, 11 times 4 is 44, we get our y value. All of our function rules in today's lesson will be in the form mx plus b, in which we are trying to find the value of m and the value of b. So we might have like y equals 3x plus 2. So to find the values of m and b, I have here m and b. M is the rate of increase or decrease in like a table of values. Another way to think about this is you want to look at how your y values change, and then you want to look at how your x values change, and then you're going to divide them. And then b is the corresponding output value when the input equals 0. So if you had an xy table and the input value is 0 and the output value is 5, whichever one corresponds to that 0 is b. So here is our first table of values. We have x, 1, 2, 3, 4, and then our y values are f of x, 5, 10, 15, 20. So our goal is to write the equation y equals mx plus b, and then to find m, this is the change in our y values divided by the change in your x values. So our y values change by 5 each time, and our x values change by 1 each time. So our change in y is 5 and our change in x is 1, and 5 divided by 1 is 5. So that means our rate of increase is 5. And then now we have to find the value of b. b, we have to find the output value when the x value is 0. So 0 is not on the table, but we can follow this pattern backwards. It's going up by 1 each time, so we just need to go backwards, follow the pattern backwards 1 to get to 0. And then since we're going up by 5s each time, to follow that pattern backwards, you would go back by 5, which would leave you at the point 0, 0. So in this case, b equals 0. So our final function rule is y equals 5x, and then plus 0, you don't need to write. And then you can always double check. After you get your equation, go back and start plugging in values to make sure they work. Let's see, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and 5 times 4 is 20. So always go back and check that your equation works for all values in the table. Okay, here's our second relationship. Our x values are increasing by 2, and our y values are increasing by 6. But remember, to find the rate of increase, you have to look at the change of your y values and the change of your x values and divide them. So our change in y values, they're increasing by 6. And then our x values are increasing by 2, and 6 divided by 2 is 3. So for every one value of x, y increases by 3. And then b, remember you want to look for 0 in your input column, and then whichever one corresponds to 0, that's your b value, 6. So b equals 6. So once you have your values of m and b, you just have to input them into the function, the equation, y equals 3x plus 6. There's our function rule. And don't forget, after you write it, go back and check. Pick a random one. Let's say 4 and 18. Plug it in and see if it works. Is 3 times 4. Let's see, 3 times 4 is 12, and 12 plus 6 is 18. So it checked. Okay, in our third example, let's see, we've got our y values. How are our y values changing? Looks like they're going up by 8 each time. So our change in y is 8. And now our change in x values, they're going up by 4 each time. And so change in x is 4, and 8 divided by 4 is 2. So our rate of increase is 2, and now we have to find where is 0 on our input side. It's going to be somewhere in between these two ordered pairs. So I'm going to kind of make an extension to this table. We have -2, -1, 0. So at -2, this is given to you as 4. And now go back to what we found for m. Every time x increases by 1, y will increase by 2. So at -1, we should be at 6, and 0, we should be at 8. And if you follow that pattern, it should match up with the rest of the table. So 8 is the output that matches with the input 0. So b equals 8, and our equation is y equals 2x plus 8. And then pick a random value to check. Let's look at 10 and 28. If we plug in 10, 2 times 10 is 20, plus 8 is 28, so it checks. For this last example, I want you to pause the video, see if you can figure it out on your own. You should get that y equals 0.5x plus 5, but before we're done, let's pick one point to check. So let's look at 4, 7. If you plug in 4, half of 4 is 2, and 2 plus 5 is 7, so it checks. So there is your lesson on writing function rules, and specifically linear function rules. Good luck with the lesson.